A very good morning, good afternoon and good evening to all my dear friends, participants and students for this course under NPTEL MOOC, and the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, the three broad topics for this course are as follows. The first one is forecasting, second one is regression, third one is time series, and we are covering and in the midst of regression models. This is week number 8 and this is lecture number 36. What is the coverage? Coverage for this lecture would be examples of MLR in finance, and which we have just started in discussion, considering the multi-index model, which is a replica of multiple linear regression model, is to be utilized. Now, we were discussing, as I mentioned, this slide which we left as the last one in the last lecture is being utilized here also, because there is a continuity of the discussion which we do not want to break. So, the first equation which you have here, I will highlight it. There may be repetition, plus please bear with me. First one is actually the estimate of beta given by beta hat. You know x transpose, which is x to the power t, which is this one, which I will put a tick mark with a different color, dark red, multiplied by x, and you take the inverse. The third term which you have after the inverse, because the inverse consists of two terms. So, third term you have is x transpose into y, which is y is the fourth term, and then multiplying that, remembering the dimension concept should be maintained, you actually have the value of beta hat. And as I was talking about the dimension part, so the dimension of y is n cross 1, dimension of x is x transpose is k cross n, and the dimension of x transpose x is given by k cross k. So, dimension of x transpose is inside the bracket is k cross n and x is n cross k, hence k cross n into n cross k gives you k cross k. K I am considering as the number of independent variables. Whether you have k plus 1 considering the constant term, the idea remains the same, that is about the dimension. Covariance of beta hat is given by, again I am repeating, sigma square is the variance of the corresponding to the error term, and again in the bracket which you have transpose x inverse, and the dimension of this obviously would be, I am using the red color, is k cross k, and each term being multiplied, each term means x transpose x, that inverse being multiplied, that matrix being multiplied by sigma square, where the principal diagonal are the variances of betas, that is the 1 cross comma 1 element is the variance of beta 1 square, beta 1, and the k cross k element, the last one on the right hand side bottom, is the variance of beta k, and the of the diagonal element are the covariances existing between the ith and the jth values of beta, where I and j are all between 1 to k. And the last term again repeating is the standard error square, and it is given by the error square divided by n minus k, and I have in detail explained the concept of n minus k, where n is the sample size and k is the number of independent variables, and it is losing degrees of freedom based on the fact that you are utilizing one set, that is x1, to find its mean. So, you lose 1 degrees of freedom. Then you use the second set x2 to find its mean, you lose another degrees of freedom, and corresponding to k number of random variables independent, you lose k number of degrees of freedom. Hence, it is divided by n minus k. We have also discussed, I am sorry for the repetition, we have also discussed total sum of squares, regression sum of squares, error sum of squares. Total sum of squares is the total amount of variability which is divided into two parts. The first one is regression sum of squares, which is explained, and error sum of squares, which is not explained, and we will utilize these three terms to find out the ideas of R square and adjusted R square. Now, in order to explain total sum of squares, error sum of squares and the regression sum of squares, I marked them in the diagram. This diagram is taken from Econometric Analysis by W. H. Green, which is a classic book. I have utilized that with the reference so that somebody is interested can utilize that, and I marked it where the diagram is and what are the corresponding SST, SSE and SSR. Now, if I consider the total sum, it is actually the difference between yi minus y bar, square them and sum them up for all the readings 1 to n. Hence, it is marked as SST, and this is actually this point which you have in this line. This is the best fit line, this is the average. So, the average is given by y bar along the y axis, x bar along the x axis, and this point, as we know, will be satisfied by this best fit line. And the point which you have yi, xi are given. I will use a different color. This is xi, yi, this point is given, and that point gives you the idea that the difference from yi till y bar is actually the one which is shown here by this, the curly bracket. Yi is this point, y bar is this point which I have already marked. I am using the black color, but as required I will remove the colors as we proceed. The difference between them gives me this, which is the difference of yi minus y bar. Square them up, again I am repeating, add them up, that gives you the total regression error. Now, if I come to the part corresponding to the regression residuals, that is simple. I have regressed and found out y hat minus the y bar would be given by the concept of the regression component error. Square them up, sum them up, that gives you SSR. I will use a different color, consider dark blue. So, this is the part yi hat minus y bar. Y bar I already know, yi hat is actually on the regression line. Difference between that is given by this point, which is y hat minus y bar. Y hat with this corresponding suffix to the reading, but I am not talking about that. And finally, the error term. I will use a different color. Consider I will use consider red one. So, that is given by yi minus y hat, that is the difference between the actual value and the predicted value. Actual value yi, predicted value yi hat, and that is given by the error which is coming from the non-explained part, coming from the white noise, then you square them up, sum them up, and that is given by the sum of squares of the errors. So, if I have, again I am repeating for this part, summation of yi minus y bar square for all the values of n, SST, summation of all the values corresponding to y hat I minus y bar square for summing up for all n is given by SSR. And finally, the component corresponding to summation of yi minus y hat I whole square for all the n is SSE. The red part not explained, outside, the green part total, and the yellow part which is explained, because I am repeating it because they will be utilized time and again. Now, utilizing that, we have the R square and the adjusted R square, and remember the concept wise, R square is actually the total regression part which is explained divided by the total sum of explained part, not explained part. And if I utilize that, R square gives you, say for example, in a very simple layman terms, the percentage or the not the probability, the decimal concept between 0 and 1 about the component which you are able to explain about the concept of y being predicted utilizing the concept of x, which are the independent variables. And the adjusted R square is, very interestingly, you are now trying to find a certain sort of mean value. And what is the mean value? If you notice here, the error term is divided by n minus k, and the total sum of the total deviation is divided by n minus 1. And this n minus 1 and n minus k are the corresponding so called average value, which brings into the picture that what is the quantum of the SSE divided by n minus k would give you the average concept, because n is the sample size, k is the degrees of freedom which is being lost. So, for the total sample which you have, so called sample which has been adjusted, what is the total amount of error on an average which is there, which is coming from the white noise outside the ambit. And if I consider the concept of SST by n minus 1, it actually gives me the total so called deviation, which is coming from the concept that there is n number of observations, and one is actually coming from the fact that you have y and you are utilizing all the information from x in order, x plus the error term, in order to give us the idea of the total deviation. So, the total deviation, again I am repeating, consists of coming from the independent variables and coming from the error. Independent variables coming is regression SSR, coming from the error is SSE, sum of that is SST, and based on that we utilize R square, which is the so called percentage without the average value of the total deviation which is explained for y based on x, and adjusted R square is again the total amount of deviation which is explained by x, but considering the on an average considering the sample size, where in one case it is n minus k depending on the degrees of freedom lost, and another case is n minus k considering that you are utilizing n minus 1, n1 coming from the degrees of freedom lost based on the fact of y. Now, the fact is actually, if you look at this formula, intuitively you will see that n minus k dividing by n minus k and dividing by n minus 1, technically the R square adjusted value should increase. And increase means that on an average, if you take the amount of prediction which is actually for the x's, if it increases means that is right. But in many of the cases, the adjusted R square may not be equal to R square, on the contrary, if it can be less. There one has to be careful. And why I am mentioning that, in many of the problems which we solve later on, you may find the values of adjusted R square is low. Now, does it mean that the way of solution is wrong? No. It means that the choice of the variables which we are utilizing has to be cultivated in order to find out the best set of variables of x which predicts y. Now, that if you do, again it will take a lot of time in order to explain. So, rather than trying to explain the choice of x, I will immediately come to the problem solving as we are doing and explain the concept of, as I did for R square and adjacent R square, as we proceed to solve the problem. Consider model 1 for the multiple linear regression, and we will take the idea what we were considering, the idea for trying to predict for Tata Motors returns based of NSE returns and other X values, and I will explain what they are. The first model consists of yi, which is the dependent variable we are taking, is explained. There is no beta naught term, that means there is no intercept, is given by beta 1 into x1 I is basically the number of readings, plus beta 2 into x2 plus beta 3 into x3 that means there are 3 independent variables and we are considering that they are independent, which means x1, x2, x3 are independent. All those tests I am omitting, that because that will again go into the realm of trying to do more detailed statistics. I will assume them to be true and proceed. Obviously, you will find out some of the answers may not be up to your satisfaction. Don't worry about that. Main idea is to solve and understand the basic steps how you solve the regression models. And the last part is the error which I am circling as it should be. This is the first model we are considering and we name it as model 1. What are the values of y? What is x1, x2, x3? Here, y is Tata Motors stock closing price returns given by ln of price of day t of Tata divided by price of day t minus 1, which is actually the formula ln of SP2 divided by SP1, which we have explained. X1 is NSE 50 closing price. Again, the closing price concept is important for both Tata and NSE because closing price gives us all the information throughout the day. So, let me continue reading. NSE 50 closing price returns given by ln of P of price of NSE at day t divided by price of NSE at t minus 1. X2 is the Indian rupee to US rate given in Indian rupees, and X3 is the Brent crude price given in euros. Now, these informations have been taken from the website, and I will come to this problem solving again utilizing the Excel sheet, which I always do. So, I will now switch on to the Excel sheet. So, this was actually for the case of NSE and Tata Motors. That means, it was a simple linear regression model. And all the data and everything is there in the Excel sheet. It will be shared with you. As the PPT slides will be shared, the Excel sheet should also be shared, would be shared. Now, if I come to the multiple linear regression model, which I have taken again from February, March, April, May, June, as you see for 2025. So, that is given in column number A, as you can see. The second column number B, because these informations are given in this sheet at different positions. So, that is why I keep mentioning the column. This is given in column number B, Tata Motors, and I am taking the returns, not the prices, because I have copied the returns here. The next column C is in the NSE returns. The next column D is actually the Indian rupees to US dollar rates, and they are taking from the website. I am not going to come to the website when I am taking, but their actual data set. So, if I give the information Indian to US dollars on 3rd February 2025 was 86.7 and 30th June is 85.1. Similarly, if I have the Brent crude, the prices are, the first price on 3rd February 2025 is 76.49 in euros, and on 30th June 2025 is 68.15. I utilize this data, and actually the part which I am highlighting now here, which is column C, D, E for all the data points for February, March, April, May, June is actually X. So, what is X1? X1 is NSE 50 price returns. What is X2? Is the Indian rupees to US dollars. and what is x3 is the Brent crude price. So, there is x1, x2, x3. And what is n? N is basically number of readings, which is the data points corresponding to February, March, April, May, June, the number of data points. So, let me check the number of data points. It is 99 in number. So, n is 99 and k is 3, and y, as we know, is the value given corresponding to the return for Tata Motors. So, with this I will now switch back to the PPT slide to further on give that analysis. So, again I am repeating, I have mentioned what is x, the dimension, I mentioned what is y, its dimension. Based on that we proceed to solve the problem. So, now I put it in the formula which we already know, beta hat is given by x transpose x inverse into x transpose into y. I have already mentioned what is x, we know x transpose, we can find out, we already know what is y. Based on that, when I find out the value of beta hat, which is beta 1 hat, is coming to be 1.2478, beta 2 hat is 0.0005 and beta 3 is minus 0.0006. Similarly, when I utilize the formula for the covariance of beta, the formula was already given, which was sigma square into x transpose x into of that inverse, and sigma square we had considered as, if I'll most probably I'll come to that later. So, that value comes out to be the covariance. The first 1,1 element is the variance of beta 1 with itself, which is the covariance of beta 1 with itself, which is the variance. 2,2 is value which is 0.0004 is the variance of beta 2, and the 3,3 element is 0.0006 is the variance of beta 3, and the of the diagonal element which you see 1, 2 and 2, 1 is minus 0.0277 and 1, 3 and 3, 1 is plus 0.0323 and 2, 3 and 3, 2 comes out to minus 0.0005. So, what does it mean? A value of minus 0.0277, immediately the minus sign gives me the idea that the correlation existing between x1 and x2 is negative. Now, you can immediately ask between beta. Similarly, the correlation existing between beta 1 and beta 3 and beta 2 and beta 3 can be said to be positive and negative respectively. And when I use the formula utilizing for x square, remember n is 99, k is 3. So, in the denominator when it is n minus k, which is 99 minus 3, based on that formula when I find out s square, it comes out to be 0.000026909. So, with this information you have all the information which is required to proceed for the calculation. For the R square analysis, R square I will come to that later. Now, the actual model 1 becomes yi is plus 1.2478, then the second term, so that is beta 1, beta 2 is 0.0005 into x2 minus of 0.0006 into x3. So, beta 3 is minus 0.0006 and actually the error term is there. So, this is the regression model which you have, which you are utilizing on the multiple linear regression concept or the multi-index model which you are considering to predict the return for Tata Motors based on the fact that you are considering the x1 as NSE 50, x2 as Indian rupees to US dollars and x3 as Brent crude price. Now, there can be different questions coming up from in your mind that normality should hold true. Yes, I have not checked, I understand, but it is the idea I am trying to give. Then the independence between the random variable should be checked, x1, x2, x3, yes, it should be done. Then considering a fact which I keep mentioning, time series concept have autocorrelation and this concept of heteroscedasticity, those all things should be checked. I am considering, again I am repeating, I am considering from the very simple fact that how the regression model should be solved. Those tests and everything should be performed rather than considering them at one go in this course, I thought I will just give you the idea of utilizing the regression model that would come under the purview of statistics and advanced statistics concept. Now, these are the residual plots for the data. The residual plots can be done in two ways. Number one, these 99 data points I have there. So, if I have extra more data points, so based on the beta hats which I found out, I can find out y hats, set of y hats. So, consider I have from 100 to 120. So, these the extra set of points which are there, for which already I have the Tata Motors returns, I can utilize the data set for this extra set of x values which will be there, x1, x2, x3. For the 100 to 120 data points, I can utilize and find out y hat, and difference between y and y hat will give me the error terms for the 100 to the 120th data. When I plot that, that is the residual plot, and this is given. So, the residual plots are given, and it may not give you an idea that is exactly normal with zero mean and the variance as fixed, but it does give you as an idea that yes, the error term is almost, for the small sample we have taken, the average value would be almost 0. Now, if the error term was exactly normal with zero mean and a variability of 1 or sigma square, which sigma square being constant, then the graph would look like this. I will use a different color here to highlight that fact, which I have already done in many of the examples, but still I will do. So, it was a normal with zero mean and variance being sigma square and variance not changing. The error terms would be this, mean value being 0 and variance being fixed. So, this is basically the concept of the model 1. Now, we will like to continue with by considering the concept of model 2, where rather than taking only x1, x2 and x3, which means beta 1, beta 2, beta 3, I will add the concept of beta naught in order to solve the problem in more details, where now we have an intercept, and then compare the values of, in the first set what we did, we found out beta 1 hat, beta 2 hat, beta 3 hat. In the second model, which is model 2, we will find out beta naught, then beta 1 hat, beta 2 hat, beta 3 hat. So, we will try to see the comparison just visually, the values of beta 1 hat in both the cases, model 1, model 2, similarly do for beta 2 hat, beta 3 hat for model 1 and 2, and also plot the error terms in order to have a feel that how the error terms fluctuate. So, rather than starting the model 2 in all the details, we will start in the next class and discuss in details. Have a nice day and thank you very much.